Okay. So we're going to talk about the AI infrastructure, how it's supporting the application. That's really interesting. And then what we use to build it and secure it and lock it down and manage the AI workload through its entire life cycle. So we're going to go through building a model, training it, testing it, deploying it to staging, looking at it, do we like it, not like it? If we like it, pushing it into production, and how all of the steps involved in doing that, and how the various components of the stack help you manage that, and the things you have to do and the things the stack does for you. So this is pretty standard DevOps kind of MLOps activities in training a model. You know, data collection and preparation. We have a data set that we're going to pull. We're going to have a model that we're going to grab, and then we're going to train, and then we're going to serve that model up into a production environment after we validate it and refine it and test it. The data collection that we're going to use in this example is, well, I can say it's ridiculously small. We used 13 data points to train our model. And then we modified the model. We did a training, and it came out, and you'll see it comes out poorly. And then we modify the algorithm to train the model, and we do it again, and we get better results. And the point is that you can go through and change the data, you can change the model, you can version things, and the infrastructure is going to help you guide you through all of that component and the maturity of training the model. So the AI platform is, in essence, pretty familiar. You're going to see generically, you can take AI models, you can take the AI workloads and or the models that you want to load up and the libraries that you're going to build it. And the one we're going to use, I'm going to show in a second, is based on TensorFlow. It's going to run on top of accelerated CUDA operators and GPU network operators within RKE2. And that's all being managed by Rancher, and NuVector is what's providing the security for the whole stack. Generically, we can run this on Harvester or SUSE Linux Micro, and on top of any hardware infrastructure we want. And if we look at it, in our example today, what we're going to be using is a Keras-based model that are trained with TensorFlow and using a GPU device plugin that's built into a container. And we're going to use that to then build out and train our model as what we're deploying and managing and pushing forward. So when you plug it into the stack, it looks like this. I mean, and this is, for me, this is, well, I don't know, I like the way the slide looks, but it's a descriptive slide. Because what you see here is the AI stack that we showed before here, which is really a SUSE stack. This is SUSE infrastructure, all in all. When I create the SLE-based container with Keras TensorFlow and the high-speed GPU plugin enabled in it, I'm giving the stack the flavor of AI that I need it to have for the purpose I want it to perform. And I could do that with TensorFlow, so I can build and train a model. I could do that with OpenWebUI and LangChain framework if I already had a model and I just want to augment it. Whatever I plug in here, whatever AI components I plug into this stack, it'll take and then take on that behavior, and then I can manage it like a standard container application and workload. And that's what we're going to go through here today. Is we're going to take this image or this container image, we're going to plug it into the stack, and then we're going to run it through the entire sequence to train, deploy, and manage the model. I should probably ask for questions. What we're doing here in the specific example is we're going to not run it on just generic hardware. We have a data center deployment for excuse me, I'm still getting over something. A data center deployment for our management cluster, and it's where our staging cluster is. We have an EKS cluster, NVIDIA-based EKS cluster. That's where we're doing our training. And we have a production cluster that's in EKS that's separate, that's also on AWS. And that's the environment that we're going to cater to. So training is on EKS, staging and testing and validation is on-prem in the data center. When it goes to production, we promote it back out to EKS. But before we do that, we actually pull in, and we're going to pull in GitOps or GitHub and use that with S3 buckets, because we're going to invoke Fleet and pull the whole thing together with Rancher and Fleet. Excuse me, I'm losing a bit of my voice. So the deployment model is data center, cloud, and then the GitHub repository. I guess I should just take a step back on the GitHub repository. The way Rancher works and the way we can manage it in the stack, when I look at this stack, is I can actually have things outside of the stack. I can store models, I can store data in GitHub GitOps, and if I check something in, I can have Rancher automatically see that check-in and deploy that out to target clusters. And so what I'm going to do is I'm going to set up, or what we did set up was a GitOps environment with all of the data actually stored in S3 buckets and the model stored in S3 bucket. And then when we check something into GitOps, if we say it's checked in for training, then Rancher will automatically deploy it to the training cluster so that we can train. When we pull it back out and we validate it, and then we're done with that, and we say it's good, we can validate it and say we'll check it in for staging, it'll automatically deploy it to staging. And then when I say it's good there, if I like what I see in staging, if it's stable, it's good, I check it in on GitOps and it'll automatically deploy to the production environment. So really, I only have to work with one thing. I have a very simple thing I work with. And the platform and the infrastructure will manage the AI application and deployment into all its various stages throughout its life cycle. So again, the three clusters that we used in this example are on-prem and two in AWS. The deployment model on-prem is I have a control plane that's Rancher, and that's just my control plane. It's not really part of the AI system. It's just what I'm running. And then I am creating a cluster that's for staging, that's got the components and the SLE-based TensorFlow container. And then I've got the two in AWS, and that's really what I'm deploying. And notice the stack does change. And this doesn't matter to the AI application, and it doesn't matter to the way you manage it or interact with it, and it doesn't matter to the way the deployment engine works. When I'm deploying on-prem, it's deploying to SLE Micro with Rancher and in the Rancher environment. When I went to Amazon, I selected the environment where I'm not using Rancher anymore. I'm still managing, I am using Rancher, but I'm not using RKE2 anymore. And I'm not using SLE Micro. I'm letting it run on EKS. That's perfectly valid. So everything I do to manage it, everything I do to run it, everything that triggers to have auto deployments and all, stays the same. I don't have to change anything. It's all just maintained within the Rancher ecosystem. Yeah. No, it's not, I just use that as the demo. And that's a good question, and ask those all the way through, because this demo is just a point of an example of the kinds of things you can do. Again, I could have done this on AKS on Azure. I could have done this on GKE on Google. I could have done the whole thing on-prem, or I could have done it with K3S and then RKE2. Can I deploy this to OpenShift?
Yeah, OpenShift on-premise?
I suppose so if you use OpenShift as a runtime, though Rancher is really a management environment and so in this example what I'm doing is I'm using Rancher and this whole system to deploy to the infrastructure. So if you're just using that as a runtime, I don't see why it wouldn't work. But
it doesn't really make sense because
it's
OpenShift is also another management platform, just like Rancher is.
Yeah.
Except Rancher has some very specific features that are far more. It's more scalable, more modular. So I don't see the combination working out well. Theoretically, maybe possible, but I don't have a good answer for you.
But I mean, you go out to the farthest edge of what I would consider a use case. But within that set of use cases, I mean, there are so many places you could deploy it to. It wouldn't matter. It's really okay as long as it's basically as long as it's a standard Kubernetes environment. You can. So this is really the automation workflow. I'm not going to dive into it, but I am going to use this picture later. It looks complex. It kind of is complex. And when I get into the setting up of the environment and then the way we walk through it, I'll walk through the steps and then I'll talk about what's automated and what really all you have to do is. And so to set up the environment, and there's this little demo here, and actually happens again in the full demo, but I'm going to play it anyhow because it's only 23 seconds. All it's doing here is we're going through, and it's not very clear, is it? we're just going through and labeling the clusters as the target clusters so that we can then use Fleet to target them and auto-deploy. And it's really all that we have to do. We're creating a label for environment for training, an environment for staging, an environment for production. And once those are done, then I'm set. You can see my bar. So after we set up the clusters, what we did is we secured it with NuVector, and we went through the standard environment where we did compliance, we did scanning and set up the policies. I didn't record that because that's actually a really full session all by itself. But essentially what we did with each one of the steps is we locked down all the components and all the attack vectors. And this is all part of the platform. And what's interesting about it is it doesn't just lock down the stack that we showed you earlier. So, you know, the SUSE stack with Rancher and RKE2 and all of that. It locks down more than that. It reaches out, it looks at the Docker registry, if that's what you're using as a registry, or whatever registry you're using, you can set up scanning on that. So it looks at that and scans on that system. It looks at the network policies that you want to invoke and then enforces those. And then on each of the clusters, we do the admission control, runtime on CVE scans, compliance, then check, and the zero trust control are set up on each one of the 3 clusters. And then we do a pipeline vulnerability scan on GitHub. And so, and the S3 buckets that are behind it. This basically lets us, in a single point in a single console, reach around to all the points and all the stages of the life cycle of the applications to go through and everything it touches, and lock it down and secure it. When I actually do the deployment and I want to actually go through the process now that the system's set up, this is the actual process I go through. This is the verbose process. And it's interesting because if you read it through, this is actually a kind of a distilled down, truncated, shortened version of what the engineer did that actually put this demo together. And I wish the engineer was here, but he couldn't make the trip. So Guang Yi was the engineer that did this work. And this was as short as I could make the workflow and fit it on a slide. So what's nice about this, though, is when you look at that whole workflow, if I just look at this is what I have to do. The rest is handled by the infrastructure. I check in a model, the deployment happens, it pushes to training, I can kick off the training, and when it's done, I can validate it. When it's done, it stores and I can approve it. Once it's approved, I can check that approval in for staging, and then it auto deploys to staging. When that's done, I verify, I can look at it and approve it. And again, each time I do a check-in on GitHub, I can have it move to the next stage. So even though these are all the steps that happen, this is with the infrastructure and managing of the AI application, all that you actually have to do. And then ultimately verify the production model. And so what I'm going to do is I'm going to run through the actual recorded demo. And then I want to maybe talk a little about how this is a point on using TensorFlow to train a model, but you can't do it because you're going to see a demo later on how you can use AI in a different way. Has everyone seen the AI demo yet?
There was a short AI demo this morning in the keynote. Yeah. And later on there'll be a longer demo as well. So.
Okay, well I'll talk about how that can be used with this too. Okay, great. So again, we're going to set it up, the 3 clusters. It's going to talk about the stuff we just talked about. S3 bucket for training. Go through, this is the same 23-second setup that we just saw. So I showed it ahead, but I couldn't cut it out of this main part. And so when this is done, this is the setup of the 3 clusters. Actually, it's clear, though. You can probably read it now. That's good.
And this is where the labeling is happening?
Yeah, if you see up on the top where he's highlighting in the blue. And so then now we're at model. We've got version 1 of the model. We're going to version it. We'll go into the YAML and play with that. And you'll see. Going to do a check-in, and then it's going to be deployed to the staging cluster. And he's foreshadowing that it's not accurate because it's going to be terrible. So what we're doing now is we're looking at a picture of a chameleon and a picture of the SUSE logo and asking if we can tell the difference. And there it is, SUSE logo with 94% confidence that it's actually a chameleon. And 97% confidence that this is a logo. So it didn't do real well, which is okay. We gave it 13 pictures and a simple algorithm. What we're going to do now is we're going to look at it and go, we don't like the way that worked. We're going to go in and change the algorithm and change the parameters and use augmented training on the model and just modify how we do it. And this is how we version it. We didn't like that version of the model. It didn't come out right. We're going to change some parameters. We're going to retrain it. We could go grab more data, put more data in there and retrain it. Regardless of what reason you're using to retrain it, you're going to train it, you're going to version the model, and you'll have a new version, and then you can push it through all the steps again, and it'll, again, so he's going to do a git commit, and when he does that, it's going to automatically deploy. As soon as he checks it in, then it deploys. So again, this is the part where the infrastructure is doing the work. So it's back in training. We're letting it train. It's retraining. It's on EKS because it's a higher intensity application to train. And it's going to start up here, and probably could have cut this down because we're going to sit here and watch it actually start, which is slow. Well, it's not that slow, but it's slower than I talk, so it's annoying. Time for a question.
Any questions, comments so far?
People are trying to read the screen.
Do we have a template for Guangyi's entire build that folks in the engineering SA teams can play with? I wonder. I want to find out.
Yeah, I can answer that.
Okay.
Yeah. So okay, now it's trained, and we can look at it and we can see what we think. Go through the same process we did before. Push it out, start it up. So now it's going to staging. I will point out, this is very much a demo kind of environment. In a real world scenario, I would have a dev test cluster before I had a staging cluster, and then I would have a production cluster. But this one just truncates the dev test and staging into one. So, same thing, putting it in. Gonna fire it up with version 2. And now it's deploying. And you will see better results. After it starts. Maybe I'll just take a second and say, what we did to improve the training in the model is we changed it to augmentation, augmented scanning of the model and the pictures. And instead of just looking at each picture, it starts zooming in on them and flipping around, looking at different orientations on each picture. So that it gets lots and lots of different views of the same picture. And then it noticeably makes better decisions based on that. It's starting. I've been through this. All right, just about, I think. Just like building suspense.
Were there any material hardware differences between the on-prem versus the EKS cluster?
Yeah, the EKS cluster was bigger. A lot bigger. Scaled out. So, okay, it's done, it's out there. What we can see, he says marginally improved. It's dramatically improved in that it actually gets the pictures right with even some confidence. So it's, you know, it's not what I would deploy to production. I would keep going and adding more pictures and go through this process more and more to refine it to the point where I'd make it production. But I can see in this process that when I go through this, I take these same pictures and I look at it, and it's now going to say, that's a SUSE logo. Last time it says it was a chameleon. So 55% confidence isn't where I want to be, but I'm on the right track. And now I'm going to do a picture of a chameleon, and it's going to say that's a chameleon. So not chameleon, but he's not an English speaker, let's just say. But so yeah, I mean, there you go. We've trained the model to an extent. We've deployed it. Now that we think we like what we have, we've trained it to the point where we think we could remove it. When we take this check it out of production, or and then check it in and get to production, Rancher is going to auto deploy it to the production cluster, and it's going to be live. Yeah, so push. It's always push, and once it's done, it's going to go live. There you go. So now it's pushes it to production, you validate it in production, and you're done. And that's what you do. When that goes live. Yeah, it's just telling you it's redeploying with the new model. And every time I version the model or I version my data, either time I version either one of those, if I check in new data or if I check in a new model, it'll retrain. It'll automatically deploy to retrain. And then I can do the process over. Because I think a lot of times people have and are working with data that's not necessarily static, and they need to version their data, and this helps you version the data, keep track of what you have, and then deploy so you know what you've deployed. And again, it's starting up, and I don't know that we need to watch this part again, but it is here. And then I'm going to make really one final point after this, which is kind of related to the question, that this is just a case example of a specific scenario. We could do this same stack and deployment with what you're going to see later in the demo. Instead of building a model and training a model myself, maybe I want to pull a model that's already built, and I want to take that model and I want to load it onto Ollama. I can take an Ollama container, put it in here, I can load my pre-built model into that, and I can do my augmentations to that model myself, and then I can use the same process to test it, stage it, and move it to production. It doesn't have to be training models with TensorFlow. It could be training models with PyTorch. It could be using built models with Ollama and LangChain framework. You have a lot of options here. The flavor of what you want to do and how you want to use AI has everything to do with the containers we populate the stack with. And those are very, We can populate those with really any kind of container we need for the AI workload. So there you go. It's making the version 2. It's going to production, and we test it, and it's going to do exactly what it did in staging because that's what's supposed to happen. But, you know, you have to test it. There's 2 things, Chameleon and SUSE. But there you go. Highlighted it too, I like that. Okay. I will point out that Guang speaks many languages, so English is just one of his many languages. Just kind of say the point that we just made, which is we just looked at data collection and preparation, model training, and then model serving. We could be looking at model pulling, model augmentation, and model serving. They're very different environments in AI. A lot of the world today is pulling built models and augmenting them with private data and then deploying those systems. This stack works the same way regardless of what application you push it on. And because we are containerizing the AI workloads, we get to take advantage of all of the wonderful things that Rancher and NuVector can do for a containerized environment and apply them to this workload. And that's one of the real valuable lessons here is that in the end, AI workloads, if we containerize them, aren't different. They're container workloads that we can do all of the things we always do to them and manage them and protect them in the same ways. So that's the point we wanted to make today, and that's, I don't even know where we are. We're really, but questions? You guys are as low as energy as I am.
So that was the goal, right? The goal was to sort of demonstrate the underlying capabilities of the stack as opposed to the AI piece itself. It's just another AI is just another workload, and some of the other demos that you're going to see this afternoon, some of the what you saw this morning, were basically can be deployed in production using the same methodologies. That was the goal of this demo. So at this point, I'm going to ask for questions, comments, or any other feedback that you might have.
Perfect. Thank you.
I just want to do it. So I want to start doing it. So.